Welcome students. Now in this video we are going to see the basic parameters required for analyzing the given machining problem as the orthogonal machining problem. Okay, so whenever the question it is given like that, so in the orthogonal turning operation, so this word is very important. Whenever this word is coming into the question, so what are the parameters that we have to see, okay, to take it as this orthogonal turning operation. So here of course the problem is on orthogonal turning. Okay, so which are the things that you can see? Say C alpha is the backrake angle as far as this ASA American Standard Association is concerned, and this alpha may be the orthogonal rake angle, as far as orthogonal rake system is concerned. Okay, then we required the value of uncut chip thickness T1, uncut chip thickness, okay, and we required the value of B, that is width of cut. Then the FC, that is main tangential force, and FE is our thrust force or feed force, which are the measurable forces by the dynamometer. Okay, so this thing we have to take from the question. So alpha is the rake angle, it may back rake angle or the orthogonal rake angle as per the tool signature. T1 is the uncut chip thickness, B is the width of cut, FC is the main tangential force, and FE is the thrust force. Okay, so now see, when in the question, I will take the case directly. So the question is of, say, this is D is a depth of cut in millimeter is given. Your uncut chip thickness T1 will be F, isn't it? And this D will be, and this width of cut will be this depth of cut. Please remember, very important. So whenever this feed orthogonal is given and feed is given, depth of cut is given, then you have to take it, this F as the T1 and this depth of cut as the B, that's the width of cut. Okay, so this is a common case, very important. Many times you will get this question on this. Second, we are having, say, the phase turning operation. So say phase turning, you know, so this is job and this is our tool. Now feed in this direction, so this is what? Depth of cut, isn't it? And width of chip. So here in, suppose in the plane orthogonal turning question, if say depth of cut and this width of chip is given, okay, depth of cut in millimeter and width of chip is given, then you should take this uncut chip thickness here is what? This is T1 only. T1 is equal to D and width of cut is equal to width of chip here. So this is the phase turning case. And third case that I am going to take, that is the in general case, that is when feed and width of chip is given. So in that case you have to take this uncut chip thickness as the feed in mm per revolution and width of cut is equal to width of chip. Okay, so first condition like this, see here, Say this is a plane turning operation. This is the cutting motion. This is the feed given to the tool. Okay. This is what? Depth of cut. This is width of cut. This is the feed. Okay, and this is our, say after some time tool will be here. So this will be the uncut chip thickness T1. So based on that we are getting the relationship, but in orthogonal turning what will happen? CS is equal to 0 degree and lambda is equal to 90 degree. So how this actually comes when the cutting is orthogonal? So we will see in the oblique cutting operation. Basically this is the oblique cutting operation, we can convert it into the orthogonal turning operation. Okay, so please remember one thing must be clear, that whenever and most of the times you will find this word into the metal cutting question. Okay, so whenever the orthogonal word is there, so need not to worry, just see the data and कौन सा data as a क्या लेना है, okay, you will get from here. So most of the times you will get the plane turning case where feed is nothing but uncut chip thickness and depth of cut is nothing but the width of cut. Okay, thank you.